All right, so number 11, we're multiplying some i's here. So what you're going to do is multiply the coefficients together. So -2, 6, and -5. That's going to give you 60. And then because it's a negative, a positive, and a negative, the answer would be positive. So positive 60. Okay. And then you have I, and I, which is I cubed, which will give you I squared times I. And the reason I do that is because I squared, remember, is equal to square root of -1, right? Or, sorry, my back up. I squared equals just -1. So that would make this -1, and then you have an I remaining. So 60 times -1 is -60, and then you have the I also at the end. So -60I. On 12, you have I to the 51st. So remember, there's like it's like a circle, right? You got I squared, I cubed, I to the 4th, and then it goes back. I to the 5th, I to the 6th, I to the 7th, I to the 8th, right? And it just keeps circling around. And I is the square root of -1. I squared is just -1. Oh, I guess you guys would like to see that, I bet. Sorry, there you go. So let's try it again. I squared, I cubed, I to the 4th, and then it would be 5th to the 6th to the 7th to the 8th to the 9th to the 10th, and it just keeps going in this circle. And so I is equal to the square root of -1. I squared is -1. I cubed is a couple different, I mean, you could do the square root of a negative square root of a -1, or it could just be -I, okay? And then I to the 4th is just going to be 1. So, if I take 51 and I divide it by 4, okay, it will go into that one time with 1 remaining. So and then 4 we go into 11 2 times. And this is really not the important part. That just means that it's going to go through this cycle 12 times. The important thing is that there's a remainder of 3. So it's going to go through 12 times, and then it's going to go 1, 2, 3, right? And so it's going to end up at -I. Okay? Now, if you wanted to sit here and count it and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and all the way to 51, have at it. Easier just to divide and see what the remainder is. Okay? All right. Down here on number 13, we are adding. We're not multiplying, so don't distribute here. If it's got an addition sign between it, you're just essentially adding like terms. So 7 plus 5 is 12. And then -3 and a positive 12 is going to give you a positive 9i. Now again, because we're adding, it does not become I squared. It just stays I, because you're just putting together things that are alike. Okay, and you're done. That's it. On 14, it's the same as 13, only the only difference is that you're subtracting. So you're taking 12 minus 42, okay? Or a better way to look at this is like there's a -1 here, and you just distribute that -1 to each of these. And so you're going to end up with a -42 and a positive 36i. And now you just add like terms like we did in 13. So 12 plus -42 would give you a -30. And then 10i plus 36i is 46i. And that's your answer. That's it. Now on 15, we are multiplying. Notice that there is not an addition sign between there, which means we are multiplying this guy times this guy. So 5 times 2 is 10. 5 times -4i is a -20i. 3i times 2 is positive 6i, and 3i times -4i is a -12i squared, because I times I is I squared. Now, if you recall, I squared over here is a -1. So I'm going to replace this with a -1, which means -12 times -1, this whole thing becomes a positive 12. Right? So now we add like terms again. So 10 plus 12 is 22. And then -20 plus 6 is a -14i. Down here, we have x squared. They want us to do this by factoring, but essentially you're solving this by taking the square root of both sides, right? So I'm going to take the square root of x squared equals the square root of 81, right? And when I take the square root of a square, that cancels that, and you're left with just what's underneath the x, right? And then here, 81, the square root of 81 can be a positive 9 or it could be negative 9. And again, I mentioned this earlier, when you're solving it and you actually have a variable equals whatever it is you're trying to find, you have to do its plus or minus the number, okay? So in this case, I could multiply a negative 9 times a negative 9 and get 81. So negative 9 could be the square root of 81. So when you're solving, you have to put that it could be either positive or negative 9. Okay, now, as I did this, I'm thinking, you know, really, we could have factored this. And we could have factored it if we start here and we subtracted 81 from both sides. That would give us x squared minus 81 equals 0. And this is the difference of squares. This is a perfect square and this is a perfect square. And you're subtracting, hence the name difference of squares. And so when you have a difference of squares, you put your x's here, and then you put the square root of this could be 9 or positive 9, or negative 9 or positive 9, so you put negative 9 and a positive 9. And you're going to end up with the exact same answer we got over here, because you would take x minus 9 equals 0 and x plus 9 equals 0. And then when you add 9 and subtract 9 over here, blah, 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 you're going to end up with the exact same thing, 9 and negative 9. Okay? All right. On 17, they want us to factor it and solve it. So again, there's a 1 here. There's not a number here. So we can go straight to this and put our x's here and our x here. And then we need the factors of negative 10 that will add up to negative 3. So negative 10 and 1, or 10 and negative 1, or negative 5 and 2, or 5 and negative 2, and I think that will do it. Which of these two could I add together to get negative 3? This one right here. So I put negative 5 and a positive 2. And I'm done. I'm done with the factoring. I'm not done solving, but I'm done factoring. And again, it can be that simple when it's just a 1 here. If there were a number there, we could have to do something completely different. But when it's just a 1, you can go straight to this. All right, and now we set each of these factors equal to 0 like we've been doing the whole time. And here we're going to get 5, and here we will get negative 2. All right, so some more factoring. Again, if you notice, there's a 1 here, so we can go straight to this. And really, actually first, before we do that, I'm sorry, we have to get it equal to 0. My fault. So we have to get rid of that 21. Okay, so we're going to subtract 21 and subtract 21 from this side, right? We have to do it to this side, we have to do it to that side, which means essentially I'm just moving this 21 to the other side, and when you do that, you change the sign, okay? So that gives us x squared minus 4x minus 21 equals 0. So this is what we're factoring. But again, because this is a 1, we can go straight to this, right? And we have x and x, right? And then we need the factors of negative 21 that add up to negative 4. So negative 21 and 1, 21 and negative 1. We have negative 7 and 3, and 7 and negative 3. I believe that does it. So which of these could I add together to get negative 4? Yes, you're right, it is that one. Negative 7 and positive 3. So again, I could put negative 7 here, positive 3 here, or flip them back and forth. That doesn't matter. Okay? Negative 7, positive 3. And then set each one to equal to 0. X is going to be 7 there, and x will be negative 3 there. Now, on 19, notice that there's a 2. Okay? So, and we can't factor a 2 out of all these. If these were all multiples of 2, we could do that, and then it would be easier to factor. However, we cannot factor 2 out of everything, so we're going to do the AC and grouping method, which means we take A times C, and we get negative 6. Okay? So we need the factors of negative 6. So negative 6 and 1, 6 and negative 1, negative 3, 2, and positive 3, negative 2. That should do it. And we need to know which of these we could add together to get positive 5. Well, this one, positive 6, negative 1. So what we do with those numbers is we bring them over here and we divide 6 in, or break 5x into 6x minus x, right? 6x, 1x, okay? And then we keep these just like they are, 2x squared, and then we got plus 6x minus x and minus 3. Okay, so we're going to go from 3 terms to 4 terms. And now that we have 4 terms, we can group these first two together and these together. Okay, and you look and see what in this first set of parentheses, what do they have in common? Well, they're both factors of 2 or multiples of 2, so I can factor a 2 out, and they both have an x, so I can factor an x out. Okay, so if I were to divide 2x squared by 2x, I would have an x left over. Okay, another way to look at this would be 2x times what gives me 2x squared? Well, 2x times x would give me 2x squared. Then I say, okay, 2x times what gives me 6x? Well, that would be a 3, right? So if I were to distribute this 2x, I would get this guy right here. All right. Now, over here, we have a negative x plus 3, which we can't take anything out of it, but when I get to this point, I need another one of these, right? I need this other bracket to be x plus 3. And so in order to get that, I would have to multiply by a negative 1. So basically, I divided this guy by a negative 1, put it right there, and then what's left over is x plus 1. And the reason is that when you get to this part, this guy and this guy have to be the exact same, okay? And you're like, well, it has an x and it has a 3. Yeah, but it's opposite. It's negative x, negative 3, not the same thing, right? I have to have x plus 3, just like this one. Then I could take this guy that's in front and this guy that's in front and put them in a set of parentheses, so 2x minus 1, and both of them, right, are multiplying x plus 3 for my equals 0. Now to solve it, we do what we've been doing all along over here. We take each one of these factors and set it equal to 0. Okay, so 2x minus 1 equals 0. I add 1 to both sides, right? And that would give me 2x equals 1. And then I divide both sides by 2. So x would be 1/2. And then here, x plus 3 equals 0. We subtract 3 from both sides, and x would equal negative 3. Those would be our two answers. Okay? They would also be our intercepts of our graph. Okay? Here, they want to know which quadratic equation has the roots negative 2 and 3. So basically, the best way to do this would be to go ahead and just factor each of these and see which one has the roots negative 2 and 3. Okay? So we have x squared plus x plus 6. So, again, it's only a 1 in front, so that's nice. So x and x, factors of positive 6 that add up to a positive 1. 6 and 1, no. Negative 6 and negative 1, no. Negative 3, negative 2, that would give you a negative 5. The only way to get that would be to have a positive 3 and a negative 2, but that would give me a negative 6. So this guy right here is not factorable. So we know it's not him. Okay? So this one we can just cross out because it's not factorable. Right? Here, we can go x and x, and the factors of negative 6 that add up to negative 1 could be a negative 3 and a positive 2, right? Because negative 3 times 2 gives us a negative 6. Negative 3x plus 2x would be a negative x. Now, when I solve these, I get a positive 3 and a negative 2, which is exactly what they're looking for. So that would be our answer right there. Okay, on here, this super simple, right? They want to know what the solutions are. And remember, I've said it time and time again that the solutions and the x-intercepts are the same thing. Okay, so intercepts x-axis right here at -3 and +3. So your solutions are x equals 3 and x equals -3. Over here, it crosses at -6 and -2. So x equals -6 and x equals -2. And for the last one, they cross at 1 and -5. So x equals -1 and x equals 5. All right, and then you didn't have to do these because we're going to do those in January. So you may as well just cross those out. I hope that helps, and I will see you all in the morning. Bye.